Alright, so this problem we're doing today, right now, is problem 13 from chapter 6. And the problem says a large grate rests on the floor of a warehouse. Paul and Bobby apply constant horizontal forces to the crate. The force applied by Paul has a magnitude of 48 newtons and a direction of 61 degrees south of west. How much work does Paul's force do during a displacement of the crate that is 12 meters in the direction 20 degrees east of north? So, you got a box that's on the ground and it's being pushed. So, then we have a couple of things that the problem gives us. So we know that the magnitude of the force that Paul exerts on the box is 48 newtons, and that is in a direction that is, problem says 61 degrees south of west. So if we have a compass, 61 degrees south of west is going to be down here somewhere. But that doesn't really help us because we've got another angle. So theta 1 is going to be that angle, and then we have theta 2, which is 21 meters north of east. And what we really want is the angle in between those two. So we need to find them in reference to each other. So angle 1 is going to be 180 plus 61. So 180 plus 61. And that gives us 241 degrees for this angle. And then to find this angle, we're going to do 90 minus 22. And that gives us 68 degrees. So the problem is asking how much work is done as Paul pushes on the box. So we can use the equation that we know that the work is going to be equal to the integral from 0 to x naught to x1, or the force times cosine of the angle dx. Because we're assuming that the force is constant, because the problem doesn't say anything about an acceleration or anything. So the force and the cosine, because we're assuming they're constant, they'll come outside the integral. So that's force times the cosine of the angle dx d1 dt. We know that the crate moves 12 meters, so x is 12, x naught is going to be equal to 0. So we're going to have the force times cosine of the angle times x1 minus x naught squared, and we're going to have times the 1/2. So when we plug all of our variables in, magnitude of the force, this should be the magnitude of the force. So we're going to have 48 times cosine of the angle. And so that's going to be the difference between these two angles. So you're going to have 241 minus 68 times 1/2 times 12 minus 0 squared. So we can kind of simplify this down a little more. 48 times cosine of 173 times 1/2 times 12 squared. So then you just kind of have to run the math, and you get that the work is going to be equal to negative 285.9 joules. And that's the answer to this problem.